Welcome, everyone. It's my pleasure to introduce you to our speaker today for our colloquium, Jeff Wammes. Jeff completed his PhD work at the University of Waterloo, working with Meyer Fernandez and Dan Smilek, exploring learning, memory, dual task interference, and interventions that can improve memory, such as drawing. And that's where Jeff also got his interest in today's topic about mind wandering. Currently, he's finishing up a postdoc position at Yale, working with Nick Turk-Brown, where he's continued doing some of his research on learning, memory, drawing interventions, and combining that with fMRI research. Just an interesting fact about Jeff, he's very sporty, so he keeps in his trunk of his car at any one time enough equipment to play any potential pickup sport that he might come into contact with. And also, another really interesting thing, he keeps in the trunk of his car competition level bar juggling bottles. So he used to do competitive flair bartending. So I don't know, you could, like that movie Cocktail?
Yeah.
So what is like
juggle bottles all in my hand.
And then you can roll them like that. Yeah. And just in case that need ever arises, you have those on hand in the trunk of your car. Please join me in welcoming Jeff.
All right, thanks for the introduction. There is a video out there somewhere of me flair bartending that I hope never sees the light of day. But yeah, see if you can find it. So I'm gonna have you just watch this video to start. And just basically pay close attention to the guy sitting in the driver's seat, okay? This is an exercise in mind wandering right now. It's supposed to be a video, but doesn't seem to be working. Hold on. There we go. All right, so watch the guy in the driver's seat. All right, so he just got hit, it looks like, right? So an accident's just happened. But the really interesting thing is it doesn't look like he's showing any indication that he's aware that something's coming, right? So I'll play that back now with the audio, if it works.
This is the view. Cameras mounted inside the dark pure transit van. You can see the driver wasn't talking on the phone or texting. He was looking straight ahead. Slammed into the back of Jose Sepulveda's black Nissan Altima. Bus driver appears to be paying attention. Plows into the line of cars waiting to exit onto I-35. But in this view from TechStop camera released last week, you can see he never even tapped the brakes before the crash.
Right, so I like to include that video because it's a really potent demonstration of how dangerous mind wandering can be. Stakes are a little lower in the circumstances I'm going to talk about. Nobody's going to get in a car accident because they're mind wandering during a lecture, but it's these sort of kind of real world situations that I'm interested in studying mind wandering during. So I'm talking about mind wandering. This term was kind of coined in 2006 by a Smallwood and Schooler paper. Up until that point, it was referred to by any number of other kind of related constructs, but they really brought it together under one definition, and that's the definition that I use in my work, which is a shift of attention away from a primary task and toward internal information. So in the context of a lecture, you're supposed to be paying attention to what's happening on the screen or with the speaker. So anytime you shift towards thinking about your plans for that evening or what you're going to have for dinner, that'd be considered mind wandering. Study of attention generally and how this can have consequences on performance goes back a long way. Most prominently, there's some research by Mackworth in 1948 that's basically studying radar operators and how they're able to pay attention over long periods of time, doing this exceptionally boring task, which is just watching a radar tick around and looking for very rare targets that might appear on the screen. And one interesting thing that I found, though, is that there's a really early mention of mind wandering, or what I define as mind wandering, in a paper that looks like this. So this was by von Helmholtz in 1850. He was most prominently a researcher studying the speed of nerve conduction in frogs. So you'd pull out a nerve, you'd stimulate it, and look at how long it took to kind of propagate that impulse. But when he moved into research in humans, you couldn't obviously do that directly to the nerve, so he had to have them induce some sort of response when they felt a sensation. And what he found was that there was this additional confound where at the time of perceiving the signal, if someone's thoughts are occupied with something else, they have to kind of recall what they're supposed to do, and then there's a delay as a result of that. So this is like a really early mention of performance deficits that come with someone's inability to pay attention to the task at hand. Oops. All right, 1 second. So since then, there's been a ton of research on these sort of laboratory vigilance tasks. So I'm just going to show you a few examples of tasks that are commonly used to study sustained attention. What I'll get you to do, if you'll bear with me, is you're supposed to watch this red dot move around the circle. And every once in a while, it'll skip a position instead of just going straight to the next one. So if I can get you to try this, I'll just get everyone to clap when they see that the dot has skipped. All right? So I'll start that demo now. I promise this worked at one point. Okay, there we go. Oh, so it's only going one position now. There you go. Okay. I'll just let it go around some more. Good. All right, so now we'll just do this for about 25 more minutes, and then that's approximately what we have people do in the lab. So you can really get a sense of kind of how boring these tasks can be, right? We have people come into the lab, we have them do this task for, in some cases, almost an hour. And it's a really ideal situation to study mind wandering because it's almost impossible to not mind wander during a task like this. This is a sustained attention to response task, so we're going to do a similar thing. In this case, you're supposed to respond every time you see a digit, except if that digit is the number 9, okay? And just to give you some context, a collaborator and I at Waterloo had participants do this task for 45 minutes once. So try and imagine that while you're doing this very mercifully short 30-second demo. No, you clap when there's a digit, except if it's a 9. There you go. That was the first one. All right. Yeah. Yeah. So 45 minutes of that. I found the best indicator of inattention in that task is when someone's asleep after about 35 minutes, which wasn't uncommon. So in tasks like this, people tend to mind wander about 40% of the time. Obviously, that's going to vary across tasks, but what you do is you probe them periodically during this task and ask them whether they were paying attention to the task or they were mind wandering. And about 40% of the time, they'll admit to mind wandering. Yeah? 40% of the probes. Yeah. Yeah. Yeah, almost everyone admits to it at least once. Yeah. So since that 2006 paper I mentioned, research on mind wandering has kind of exploded, and it's moved out of these more low-level laboratory tasks and into the real world. So one example is Killingsworth and Gilbert had people prompted by a smartphone periodically throughout the day. They basically just had to report what they were doing, their degree of happiness, and whether or not they were mind wandering during that time. So all the different activities that people were probed during is on this list here. And there's only one activity on this list where people reported that they were mind wandering for less than 30% of the time. So I won't indicate which one that is. But all of these tasks, people are mind wandering very frequently during. And this isn't just limited to everyday life sampling. People have done this in specific contexts. I mentioned radar operators. People also do this during reading comprehension, during university lectures, which is my bread and butter. And then also while driving, people tend to mind wander quite a bit. I'm sure anyone who's done a long highway drive can relate to this. So there's tons of research showing that the rates are kind of similar in these tasks too, which have much higher stakes in the real world. So I mentioned one way of measuring it, which is you probe people periodically during a task and ask them whether or not they're mind wandering. You can also have them just identify by themselves when they're mind wandering or not. That's self-caught. The method where you probe people during their everyday lives is a more experience sampling approach. And you can also have a situation where you have people do an entire task and then you ask them retrospectively, were you mind wandering during this task, or to what extent were you? So those are kind of the direct ways to measure it without any sort of additional physiological signal. And people also try and map these reports of attention onto various behavioral performance metrics. So response time variability, error rate. Some people have done fidgeting. So if you start to move around in your seat, I'll know that you're mind wandering during my talk. When people are driving, their speed is more variable. They might follow more closely to the car in front of them. And there's lots of measures like this that are well predicted by reports of mind wandering. Eye movements, reading time. In one case, whether or not they're able to solve the mystery at the end of a Sherlock Holmes novel. And in our case, we use quiz or exam performance in actual lectures. So we're interested in studying sort of this frame of mind during lectures. And we use primarily thought sampling and quiz or exam performance. So during this talk, I'm going to cover kind of 3 major topic areas with respect to this. The first is just a few full-scale semester-long studies we did in actual psychology classes, where we probed people in every lecture to ask them whether or not they were mind wandering, just to kind of try and observe how mind wandering trends in these real-world situations. Then I'll look at a few factors that influence or interact with mind wandering in lecture settings. And last, this is going to be kind of the data that's a bit hotter off the presses. We've started looking at how we can use audio and visual features from lectures to try and predict when people are mind wandering at the group level. And we have some preliminary pilot data trying to use that information to apply interventions that kind of reduce student mind wandering. So I'm going to start here. So basically, in all of these decades of studies on vigilance and mind wandering, the common theme is that you tend to see that performance declines and mind wandering increases over the course of time on task. So the longer you have someone doing a boring task, the more likely they are to mind wander, the more likely they are to make errors. And this is true in simple laboratory tasks, in memory tasks, but most importantly, for my purposes, Evan Risco and some colleagues in 2012 found that in simulated or video lectures, mind wandering increases over time while people are viewing these lectures. The one critical thing that I want to point out with this study is that these lectures weren't actual students in courses that they had any investment in. They were students that just were brought into the lab to view a one-off lecture. So in other words, I didn't really have any skin in the game in this situation. So in our study, we kind of wanted to remedy that by looking at real-world settings when people actually when there will actually be consequences to mind wandering in your classes. For instance, you won't retain some information, you won't do as well on a test, and you might not be able to move on to the next stage or basically achieve your goals. So we went into a physiological psychology class, second year class. We were there from the start. Got probably about 75% of the students in that first class to sign up for our study. And what we would do is we'd have our instructor show the regular slide deck, but every once in a while we would insert a thought probe that looks like that. So very simple, it's kind of used pretty standardly in the literature. Which of the following responses best characterizes your mental state just before this screen appeared? So they can say they're on task, they're intentionally mind-wandering, or they're unintentionally mind-wandering. And we did this 0 to 3 times per lecture. And what that got us was data from about 150 people for, I think, 2 classes a week for about 3.5 months. So just tons of data. And what we can look at from that is aggregating across that entire time and look at whether these temporal trends in mind wandering hold up. And responses were given using the eye clicker, which I'm sure many of you have dealt with. Okay, so the first thing I want to point out is that much like in many of these laboratory studies, the rates of mind wandering are pretty high. 30% of the time, your students are probably not fully paying attention to what you're saying, which is a pretty staggering figure. But given the research in the field, it's not that bizarre. But what's kind of more surprising is that most of the mind wandering they're doing is intentional. So they're kind of purposely deciding not to pay attention. It's not that they're doing their best to try and attend, but they just can't sustain the mental resources required. It's that they're making a conscious decision to stop paying attention and think about something else. But the main question is, how do these mind-wandering rates trend over time? Because if you remember, in the last sort of 50 years of research, it's pretty consistently found that mind-wandering increases over time in almost every task. So what happens when we get into the real world and there are actual consequences to people's mind-wandering behavior? What we find is that there's actually no evidence of an increase over time in a given lecture. And this is also true when you split it into intentional versus unintentional mind wandering. So yeah, we're pretty surprised by this. It flies in the face of decades of research. There's actually quite a few lecture studies with simulated or video lectures that show this pattern of an increase over time. So eventually we're going to get to trying to figure out why that might be. But also because we were measuring this using the clicker, we want to make sure that these responses are actually measuring what we think they are. We also had to incorporate some performance measure to try and map this onto. So what we did was the lecturer is giving their narrative as normal. So that green bar is what's being currently presented. And then we pop in a thought probe at a certain point. So what we're going to do is, since we know where that probe is, we're going to pull out the slide just before and just after that probe and write a quiz question based on it. So now we have these time-locked quiz questions that we know are associated with a given probe response. We can go back and say, when this person said they were on task, how did they do on quizzes relative to when they said they were intentionally or unintentionally mind-wandering? Okay? So they're getting 60% on a 4-option multiple choice test when they're completely on task. So not amazing, considering they've literally just seen this content, but definitely well above chance. And what happens when when the people reported that they were mind-wandering is that we get this modest decline from about 63 to about 53% accuracy on these questions. And you can see that there's a slight difference between intentional and unintentional, but that wasn't reliable. So it's clear that there are costs to performance to this behavior, and it's also sort of a validation that our probe-caught measure is telling us something. So one option is we're forcing this like very complex internal ecosystem of thought into a dichotomy. You're either mind-wandering or you're paying attention. But as I'm sure everyone in the audience could attest, you're often thinking about multiple things at once. You're devoting some of your attention to the speaker, but maybe you're thinking about wine and cheese after this, or what paper you have to finish writing. So there are degrees of mind wandering. So just to highlight that, this is our shining example of what I don't hope to see when I give any talk. So I think we'd all agree that she's mind wandering, right? And then so if you look at her friend, that's a whole other degree of inattention. So it's possible that there's declining degrees of attention and that we might be able to measure those. And if we do, maybe we'd see something like this linear increase over time. So we did that. We asked people to report somewhere what their contents of their consciousness was just before we probed them, ranging from completely on task to completely mind wandering. Okay? And what we find again is that completely flat line. So it's sort of a replication that we don't find this increase in mind wandering over time. If we break it out into the individual response bins, you can see that at least the fully on task reports are pretty stable. There might be something of a decline in mostly on task in favor of these deeper mind wandering bins, but again, that's not reliable. So for the most part, the degree to which they're paying attention to the lecture is staying remarkably stable over time throughout an hour lecture. And again, we did the same sort of validation with quiz performance, got the same kind of level of performance when people are on task. But what happens when they even get a little bit of mind wandering sneaking in there? We get a little bit of a decline in performance, right? And as we go deeper into mind wandering, you see this really nice linear decrease in how well they're doing on quizzes. So this more sensitive measure, we're able to kind of map onto quiz performance as well. So we're still kind of puzzled, why are we not getting this increase in mind wandering, right? There's a few possibilities. One is that we're introducing this artificial situation in a lecture where we're essentially grinding it to a halt to show this probe slide and wait for people's responses. That doesn't often happen. It could be the case that that allows people some time to restore, and maybe they're not going to mind wander because they've had that short break. So to remove that break, we developed a less intrusive method. So instead of the clicker, we built this really kind of bespoke, really kind of rough around the edges app that people install on their laptop. And periodically throughout the lecture, it'll pop up a screen like this, where they just have to use the slider to indicate whether they're completely mind wandering or completely on task. So they have a chance to respond. It doesn't disrupt the entire class. There's not a break in the lecture, but we still get our data, which is the most important thing. And the other nice thing about this is we can sample independently from every subject. So while when we were inserting the probes directly into the slide deck, we had these like discrete points in time where we had a lot of responses from many subjects. Since we're independently sampling, each one of these smaller blue circles is a response, and we're getting really nice coverage of the entire time course. So that's beneficial. And of course, another possibility is that the instructor that volunteered to have us do this study in his class is just extremely engaging. That's a possibility. Maybe he's just really good at maintaining sustained attention over time. So we also ran a study using this app in 5 different classes. Looked at them individually and all together to try and determine whether there's any effect of time on task. So these are individual responses. You can see there's a lot of density up around completely on task. But we have really nice coverage of the whole time course. It's hard to make any patterns out of that, so I can do a moving average here to clean it up a little bit. You can see it looks a lot like a flat line. And if you just compute the correlation between the number of minutes elapsed and the degree of mind wandering, it's basically 0. So again, no increase over time. Doesn't matter who the lecturer is. That doesn't seem to have any impact. Okay. So just to conclude this was our first foray into trying to understand these temporal trends of attention during university lectures. And what we found is that contrary to these decades of research, mind wandering doesn't tend to increase over time in at least 5 courses that are completely different content. We also found that intentional mind wandering seems to be more prevalent in these settings than unintentional mind wandering. And last, that you get these kind of modest deficits in performance that are associated with declining degrees of attention. So basically, we still get mind wandering in lectures, but it doesn't behave like we would expect based on all of the laboratory findings that are out there. Okay. So as a result of this, we're still kind of searching if time doesn't predict mind wandering, what does? So what are some other factors that we can investigate that might be influencing mind wandering in the classroom? So one factor I mentioned is that other research has typically done this with simulated or video lectures, right? With naive participants who have no consequences if they completely tune out for the entire lecture. So what we did was, while we were collecting probes in an actual lecture, this is Dan Smilek, who graciously volunteered to let me use many videos of him in this talk, so thanks, Dan. We video recorded one of his lectures, and so we have the probe data from all of the students that were present in the lecture hall. Then we took people enrolled in the same class and showed them the video recorded lecture in the lab. So those people should have some investment in the course content. It's not a perfect control, but they're viewing it in the lab instead of in a live lecture hall. And we also had a group of students who wasn't enrolled at all. So they don't care about the course at all, and they're viewing it in the lab. So there's kind of three groups there to pull out these factors. So what I'm plotting here, these dark gray bars that are kind of hard to see because of the contrast, is the group level effects across the entire semester aggregated. So you don't really get any increase in mind wandering like I showed before. This is the data from just the lecture that was video recorded. So this is basically what we found in the live lectures for the lecture in question. So now I'm going to pull up the two groups who watched it in video format. And what we see is that both groups show this reliable increase in mind wandering over time. So the interaction comes out. There's also a trending effect where the people enrolled in the class aren't mind wandering as much. Aren't mind wandering quite as much. Which makes sense, right? They're enrolled in the course, so they're actually familiar with this content and they care about learning it. So this is kind of the first bit of evidence that it's actually really important that we study, if we want to apply our findings to these real world settings, it's important to actually like simulate them really closely. If people don't actually care about the content, then they're gonna behave in different ways. They have less motivation to pay attention. Speaking of motivation, that's another factor that we've measured in several studies. It's a little bit mixed with respect to the influence of motivation on mind wandering. But what we find is that if we ask people to report their motivation to learn the material, it doesn't really predict the rates of mind wandering in the tasks where we ask them just purely, are you mind wandering or not? It does, however, predict the degree to which they're mind wandering. And also in another study, it predicts how much they're likely to use their phones or laptops instead of actually attending to lecture content. So there's some evidence that motivation is a critical factor here. I'm just gonna pass over that. And then, so the last remaining question is, if people aren't increasing their disengagement over time because they're mind wandering, it's possible that the invasion of smartphones and laptops into university classrooms has led them to disengage in a different way. So even if they're not mind wandering, they might be just on Facebook or doing something. For example, when I was TAing a class, I sat in the back row, and the student in front of me was like an amazing artist, which I learned because he spent the entirety of each class like making art on his tablet instead of paying any attention whatsoever to the class. So it's possible that people are just media multitasking more over time. So what we did was just ask people, at any given point, we'd probe them and ask them whether they're media multitasking or paying attention to the lecture. And what we find is that media multitasking actually increases over time. So this was a completely separate study where we just asked about media multitasking. But in a subsequent study, we also asked about mind wandering and elaborative thought at the same time. So elaborative thought is thinking about things kind of related to the content that you're seeing, but not exactly attending to the lecture. We included that because there's some evidence from Michael Kane's group that this actually has a really positive influence on quiz performance. Even though they're not directly attending, if they're putting the effort in to kind of think and extend what they're learning, it'll improve their performance. So what do we see here? The rates are obviously lower because there's many more options, but we replicate this increase in media multitasking over time, and we also replicate that mind wandering remains relatively stable over time. So this tells us that disengagement is increasing over time, but it's just not going towards mind wandering increasingly. It's going towards your phones and your laptops. And also this is important to note, like if people are increasing their media multitasking behavior, it's important to know how this impacts their performance on these learning measures. And what we see is a negative correlation in both experiments where the more people report that they're media multitasking, the worse they do on our quizzes at the end of each class. And you can see that that impact is worse for media multitasking than it is for mind wandering. I won't get into too much detail about this, but we also included a pre-lecture probe that just asked people to pick one of 8 locations in the classroom where they were sitting. We were just curious, you know, are people who are sitting in the back, I'm looking at the back row there, paying less attention than the people in the front? It's kind of low-hanging fruit, but it happens to be true, and the data support it. There were also a subset of the participants who sat in both the back and the front, and there's some like minimal evidence to suggest that even within a subject, when they sit in the back, they're more likely to mind wander or media multitask. And then, so because it's kind of complicated to measure every possible form of off-task thought, we started in our most recent studies that we haven't published yet, just asking about engagement. How engaged are you in the lecture content? And also, how much are you understanding the material that's being presented? Now, this is kind of a push more towards applied research. Like as an instructor, you want to know what of your content is captivating people's attention. If they're not understanding and there's some consistency in the points during the lecture at which people aren't paying attention, then you'd want to know that too, so you can target particular content to review. So engagement, very broad construct, but in terms of applied utility, I think it's a good direction. And there's actually some preliminary evidence across 2 studies that we get declines in both engagement and understanding as time goes on. And this was across lectures that were 1 hour or an hour and a half. You can imagine in some of these 3-hour lectures, we might run out of y-axis by the time it's over. This is very preliminary, but so far it seems like there's some trend towards reduced engagement and understanding. All right, so factors influencing mind wandering. We found that live lectures tend to better capture and sustain attention than video recorded lectures, even if you're actually enrolled in the class that the lecture's about. Motivation plays a subtle role in dictating the degree to which people mind wander in lectures. And other forms of disengagement influence the incidence of mind wandering. So if you have media available to you, if you have your smartphone and your laptop, you might be more likely to direct your attention towards those instead of your own internal thoughts when you're disengaging. Okay. So this is going to be unpacking more of the preliminary data we've collected. So I want to emphasize from the start that a lot of this is pilot work that we're following up on with larger samples. I was lucky enough to get to teach intro psych as my first teaching assignment when I started at Queens. So 2,000 students, lots of data, very exciting. So we're going to try and unfold some of these things in these much larger classes. So these samples are only about 70 people or so. In a few of these lectures, we actually video recorded the lecture as it was happening. This was specifically for that study where we brought people into the lab and have them view the same lectures. But I'm collaborating with Nigel Bosch and Caitlin Mills in doing some machine learning approaches to trying to take in a video file and automatically predict from what's happening in the video when the group is going to be mind wandering. So the way that you do this is you can look at any location and track the pixel values. And basically, if you see those same pixel values in adjacent locations, that's some indication that there's been movement. And so you can do this automatically. You just feed in every frame of the video, and it detects when there's movement in a particular direction. So that's more or less all we've done so far is trying to detect, when the instructor's doing these coarse movements, like walking back and forth. You can pick up things like them waving their arms emphatically. And the other thing we can pick up is slide changes. So we haven't quite worked on those data yet. One problem is that it also picks up when the camera pans, but you can rule out these kind of artifacts because basically every pixel moves. So it's relatively easy to detect what's happening. And it also detects these zoom events where every pixel moves on an angle towards the interior, exterior of the frame. So you can kind of detect those things and cancel them out and only pick up the actual motion of the instructor. So I'll just show you one example video. Dan's fast, but this is sped up. So this is an example of a lot of movement. We basically ranked these videos based on the output of the automatic detection. So it told us that this particular excerpt was really high in motion. You can tell that with the naked eye too, so it seems to work. Okay, and just to put up a few more examples. There we go. I think they're all playing now. All right, so you'll be able to tell pretty quick that this side's relatively stationary, right? And this side, the cameraman, which happened to be me in this case, is frantically trying to keep up with where Dan is at any given point. The idea is that we don't have to have a research assistant or something like view all of these videos. We can just feed them through this model, and it detects with pretty high accuracy when there's high movement versus when there isn't. And what's interesting is you can use those measures to predict the group level student attention. Obviously, there's not going to be any capacity to do individualized mind-wandering detection because everyone is seeing the same thing. But based on just this automated processing of the video, you can predict reasonably well when student attention is going to be high or low. All right. And so this is just showing that correlation. And the models were trained on these 3 different classes. And you can see a correlation between movement of the instructor and degree of mind wandering. So the more an instructor moves, the less mind wandering there's going to be. I don't think that would come as a surprise to anyone, right? But the innovative part is that you don't have to have anyone rate anything. You could just feed through your own video lectures. I could feed in my own video lecture after giving this talk and probably determine that I've been mostly stuck to this spot. Probably should have moved a bit more. But this is data that the model's never seen before, and the prediction is actually really quite good in this model as well. So despite this not being used to train it at all, this is completely new data that the model's never seen. It can predict not only when the instructor is moving, but also the extent to which the students in the class will be mind-wandering at any given time. And I should mention too that there is an honors thesis student working on parsing the audio features as well. And the preliminary findings suggest that clear and confident speech, or at least features of the audio form that predict clear and confident speech, tend to predict engagement as well. Again, that shouldn't be anything surprising, but the point is that there's potential to have videos of a lecture processed in real time and detect when the conditions are particularly ripe for students to zone out. Then maybe you can trigger the instructor to kind of reorient the class or interpolate a quiz question, which we know brings attention back online. So what we've been doing recently is looking at potential interventions that we can apply on the student side of things. So how can we help our students better pay attention? And to kind of start this off, we collect just a few basic items about students' attitudes about mind wandering. So I'm not going to get into all of these because I'm running short on time, but the right side is the most positive response. So they report that they do this very often or they agree with it to a high degree. And the left is the negative response. And a few things that I want you to pull out of this is first that students really don't think that mind wandering is much of a problem in terms of whether they're going to retain the content or not. And of course, we have data to show that it disrupts performance. And our most recent data shows that their engagement is extremely highly correlated with how much they're understanding the material. So it turns out students don't have a great intuition about the consequences of mind wandering during lectures. The next thing is that students are asked to kind of guess how much they intentionally or unintentionally mind wander. There's a modest negative correlation between their predicted mind wandering and their actual engagement. But still, they're not perfect at predicting this. And then the last thing kind of captures this aspect of strategically mind wandering. So I mentioned in the first batch of studies that people often intentionally mind wander. So the questions here are kind of trying to get at, do they do that intelligently? Like, are they doing that in a way that makes sense? We don't know the ground truth, like whether they actually are, but in their opinion, they're doing a pretty good job, it seems like, because most of them will say that they report some attempt to inhibit their mind wandering or strategically mind wander. They also don't often intentionally mind wandering during content that they think is new. So if it's something they haven't learned before, they're unlikely to just purposely tune out. And the last thing is that they say that they're much more likely to try and intentionally mind wander during familiar content relative to brand new content. So that's like more or less exactly the pattern of results that you'd want people to do. So it seems, at least in principle, that they're exerting some effort to control their mind wandering in these lectures. So we thought maybe the issue is that they're just not particularly aware of when they're mind wandering, and if we give them some feedback, then they might be able to correct course and increase their engagement. So what we did is we selected a set of participants who either showed an upward trajectory in engagement over time or a downward trajectory. So we had these two groups that showed either high positive or high negative slope. And what we did was we took half of each group and gave them some feedback at a certain point. So we just said, listen, this is how your engagement works. We didn't tell them to do anything, we just told them about it. And we had a basic manipulation check where they just had to answer a question, when is your engagement lowest? And then if they got it right, they were included in the sample. So this is where I really want to emphasize that it's a relatively small group. But here are the preliminary data. So our control group is the one that didn't get any feedback, but they had similarly highly positive or highly negative slopes. And what you can see is that pre to post feedback, their engagement actually goes down modestly. And their understanding is kind of stable. So what happened in the feedback group? So in the feedback group, you'll notice that there's a main effect, but in the feedback group, there was no increase in engagement, but they didn't have this decrease that the control group had. And in the understanding measure, they actually increased in their understanding of the material from pre to post feedback. So these data are pretty messy. It's a pretty small sample, but we're excited to kind of roll this out in a much larger sample and see whether this is something that works. We also kind of expected that maybe instead of having a negative slope, it might even out and flatten out if they're really targeting, for instance, the end of lecture in that case. We don't have sufficient data to make any conclusions about that, because it's difficult to find slope differences. But at least as a main effect, we're getting this interesting interaction. And the last thing that we've developed is a set of apps. So I mentioned that we had this app that monitors student engagement. We've kind of improved that and also developed an app for the instructor's computer, which is really simple. They just pop it open and then they click start. They select which screen they want to record and then they press start recording. And from that time until they stop it, it's collecting the contents of their screen. So in my case, it would be collecting this video. It sends it to the server, and then we have some code that links it up based on timestamps with the actual student reports of engagement to make a display sort of like this. So what we have here is a timeline of the lecture. Here we have where a slide change occurred in time. And then overlaid on here is the unfortunately quite small sample. So this is just, you're not supposed to glean anything from the pattern of results here. just the idea that we can overlay these actual patterns of student engagement on the instructor's actual lecture. So with this knowledge in mind, imagine if you're teaching intro psych like I'm going to be, and you have multiple sections, you can monitor the trend of student engagement in one, then the next, map that to content. And if there are any commonalities, for example, these 2 points across the 2 sections, you might conclude that that's content that kind of needs shoring up, or potentially include a quiz question at that point to reorient student attention back to the lecture. So I think there's a lot of applied utility here for kind of improving the way you deliver your content. And also for these targeted interventions of interpolating quiz questions when we know engagement's going to be low instead of completely randomly. So just to conclude this last section, we've been able to use both audio and video features from actual lectures to both parse whether people are moving and their speech patterns, but also use that information to predict mind wandering relatively effectively. We also found some very preliminary and rough evidence that if you give students some meta-awareness about their own engagement, they might be able to reduce the extent to which they're kind of tuning out during lectures. And last, we can use these apps that we've designed to kind of highlight and potentially modify low engagement content. And so we're hoping to roll out some studies of this sort to actually apply changes to content in subsequent sections and look at how that changes students' engagement. And that's all I have for today, so thanks very much. I want to thank all the funding sources. These are all my collaborators on the various projects. That's my new labs website in case there are any undergrads you want to send my way to do this sort of work. I'd very much appreciate it. So thank you.
Yep. How about Barry? That's good.
It's really great and interesting, and particularly in regards to feedback for instructors, and often instructors don't have much training and instruction on how to make their sessions as engaging as possible.
Right.
And I'm curious about the mind wandering, and it was shown how there was the score was less on the quizzes for those who mind wandered more.
Right.
Is it known if their overall score in the course was lower?
Yeah. Yeah, so you'd expect, they're mind wandering during these lectures. They can still go home and review the content. Maybe it's not just the right time for them, like they're not a morning person or whatever.
Okay.
We actually find modest effects on exam performance as well. I didn't show those data, but
At least I think it's intentional mind wandering, unintentional mind wandering predicts exam performance. And then intentional mind wandering predicts quiz performance, which has an effect on long-term exam performance. So they both have either direct or indirect effects on how people are going to do on the midterms. Yeah.
Great talk. There's a few probably obvious factors that probably detract from paying attention, like sleep deprivation,
Right.
night before partying,
Yeah, sure.
binge drinking, that sort of thing. Try studying, people.
Okay.
And maybe on the positive side, I wonder if you look at things like note-taking behavior, which should
Yeah.
maybe foster that broader thinking and generalizing.
Yeah, so
so
we haven't directly looked at that yet. I'm sure that it would be really informative. We're kind of hoping to get at not directly note-taking, but the sort of person that does note-taking with that elaborative thought manipulation. And because previous work had found that elaborative thought increases quiz performance, and we didn't find any changes there. And in that case, actually, because we're collecting using the app, we didn't have quiz performance to directly match it to. But I imagine that if we were able to pull out those time-locked quiz questions, we'd find a positive effect, probably with note-taking as well. Yeah, I haven't really looked at that directly, though. And
More because it would be educational for students to be told, we have definitive data on this. So don't do
Yeah.
the all-night party and get enough.
Right, yeah.
Devices is another important message in your life. I think it could be really good outreach to students
Sure.
and know about these things.
Yeah, and I think in these, now that I'm collecting much larger samples, so I think Joe's actually going to run the app in his class. I'm running it. Some people back at Waterloo are going to run it. And the great thing there is with so many participants in your sample, we can ask more questions of that sort. We have done a bit with hours of sleep. We ask them before every lecture how many hours of sleep did you have. The findings were kind of perplexing. It actually showed that, because we have for each subject multiple observations, so we can look at in that subject when they sleep more than average versus less than average, how does that change their engagement? And we actually found a correlation such that if people sleep less than average, they're more engaged, which is exactly the opposite of what I thought would happen. Not sure what to do with that data yet. Definitely needs a replication. But yeah, so hoping to do more of that.
We were also talking about, we're interested in, so Jeff showed the difference between a live lecture and an online learning material. So we're actually kind of interested in our introductory psychology course, when they are engaging in online materials, how is their mind wandering affected, because people make different choices of when they're watching it, what time of day, how close to the actual quiz. So all these kind of natural factors, and then we would love to measure mind wandering probes across the population while they're engaging in the materials. How about Dan back there?
Yeah, very interesting and lots of food for thought.
Thanks.
I'm interested in the instructor walking around and the causality conclusion about that. Is it really that the instructor walking, or is it that maybe, I can think of various things, maybe the instructor walks more, but the instructor's excited because that's such an interesting slide.
Yeah,
exactly.
Correlation like that, or either the intonation of the voice of the instructor of all walking versus not walking.
Yeah, I mean,
the
other thing is if you notice
someone's
someone's
not
paying attention,
not
it
paying
probably
attention,
makes
it
sense
probably
to
makes sense
walk.
to like walk right in front of them, right? So yeah, I mean, I don't think we have the precision exactly to do that. So a lot of the motion detection is in pretty long time windows because we didn't have a lot of data. We're hoping to whittle that down to much narrower time frames so we can get at questions like that, like just like time lag engagement versus movement, and see what the directionality is there. I think that's super fascinating and probably actually more informative than these more correlation-based measures. So yeah, maybe I'll have an answer in a year or so. Yeah.
Curious about an effect of the content itself. So
Yeah.
if there's any, what I can imagine, what would seem to me to be trivial is that people would mind wander more if the content is way too challenging, or if it's way too easy. There's probably some sweet spot. And I'm wondering if that's been tested empirically in this paradigm, and maybe tested across different lectures. Like this is an intro to psych.
This is, so some of the data were
physiological psych second year,
and other studies were that
intro
to clinical psych, intro to cognition.
cognition.
We had a few people from stats, so it's a cross-section of lectures.
I'd be curious if the results would carry over to a radically different context, like you're learning how to do something physical.
Yeah, or like
breakout activities,
group discussions.
Yeah, I mean, in terms of changes over time, there's not much out there in kind of different types of lectures, but we do know that there tends to be roughly the same. Like I think about 30% of the probes in group discussion-based lectures are reported as mind wandering as well. I think your other question was about difficulty. So I think like those kind of U-shapes have been found in reading difficulty. I think Noah's done a bit of that. But in our case, I mean, the only available data we have to speak to it are that engagement and understanding comparison. So you'd think if it was particularly difficult, you'd say that you don't understand. If it was particularly easy, you'd say you understand quite a bit. And then you'd expect that corresponding with that, you'd have a sort of U-shaped function. So we played around a bit with fitting individual subjects data with like a linear pattern versus a quadratic. there are some subjects who show that quadratic pattern, but I haven't had a chance yet to break those out and see whether there are group differences. I think it's really interesting, though.
Sorry. Go ahead.
Go ahead.
So the pattern that you went after and failed to find over and over again a bunch was, the increased mind wandering over time. Like getting kind of at Lucas's question. The kinds of tasks in which those effects are shown are like the kind you made us do at the beginning. They're boring.
Sure.
No semantic content. There's nothing to sort of ramp up engagement. And so I guess I just wondered if there's, have you pushed the bounds, on lectures? I would imagine a dead boring lecture for any number of reasons might be the kind of pattern that you're looking for. And there might, if you want to go after that, I'm not sure that.
So I won't. So in
the one circumstance, we had 5 different lectures, and having videotaped 3 lectures from each. But it's a fair point. This is definitely much more engaging than those clock tasks or Starry Night or whatever. But Risco found really strong increases in lectures as well, right? In reading comprehension tasks, you get them. In memory tasks, you get them. I think it'd be interesting once we've isolated using the audio visual features, what makes students mind wander a lot. It'd be interesting to find out what makes a lecture so boring and try and have an instructor act that out and determine what the trend looks like. I think there's a lot there. And I think it kind of goes hand in hand with measuring these factors that influence mind wandering and trying to develop interventions. We first have to kind of understand the bounds. Sorry.
iClicker responses, and I found myself making a value judgment, I think, where I was very hesitant to ever say when I actually was mind wandering.
So the act of being probed itself.
Yeah, I kind of think, oh well, maybe I was only like
I don't want Joe to know.
10 second mind wandering. I won't count that.
Yeah.
And I'm wondering if there's a way you can control for a value judgment and make some sort of, I'm not sure how to do that.
Yeah, we were kind of trying to get
at that with the
degree question,
short mind wanderings where it might be
mostly on
task or
something. Were you
sort of asking like
what the role of knowing whether or not the instructor is aware of your mind wandering behavior is?
No, more about students making value judgments about mind wandering being a bad thing.
I see.
So
I see.
Telling the professor that I was mind wandering.
Or are you even capable of judging whether you're paying attention?
So that was one of our biggest
concerns going in is like, are we just going to be getting noise out of these measurements? That's why we included the quiz questions, going to make sure we are able to block this into something real and measurable. And I think that gave us a little bit of confidence. I'm sure there's some people are still given pause when they have to say that I completely wasn't paying attention to this lecture. And so it's possible, but I would say that the rates that we get are mostly in line with what you get in those basic laboratory tasks.
So sort of a little bit question, but you just had a chance to see that. So what do you are you satisfied with mind wandering probes as a measure of mind wandering?
Yeah.
Or do you think we need other alternate measures that are needed?
So Dan was mentioning that there's some eye trackers coming in. My collaborators who are doing some of the machine learning stuff have had great success looking at like scan paths to predict when people are mind wandering. There's research at Queen's showing that these kind of like freezing and fixation is associated with mind wandering. If we could have those measures in real time, I think it's maybe more of a unbiased window into what people are attending to. That kind of gets at your question as well. It's still a little bit indirect, but it's more continuous too. We have data from the entire time course that we can potentially validate with thought probes and then leave thought probes out in subsequent studies. I'm not sure about the possibility of decoding attention versus inattention using EEG, but that'd be an interesting method as well.
More questions, and we'll go to the reception.
I'll make it quick.
Sure.
You kind of alluded to the professor also being sensitive to lapses in attention of people in the class and maybe walking around.
Yeah.
Yeah.
Why do professors implicitly pick up on that lapse that goes from the start to the end of the lecture, and they compensate
Up
and
there.
gesture more and pace more, and so that's why in the live lecture you don't see as much of the decrement, right?
Yeah,
So
yeah,
the live
yeah.
feedback is there for the instructor.
Yeah, I mean, we haven't
I mean, we
looked
haven't
at that yet,
looked at that yet, but we could with the
have.
data we have.
could pretty easily determine whether instructors are starting to move more
towards the end of lectures. Yeah, it's very intuitive. I actually don't know why we haven't done that yet. It's a good idea.
Yeah, that's a really great point. When
Yeah.
you're actually giving a lecture, I think there's an interaction that you feel, and
Yeah.
make these like small adjustments, and I think people in the audience feel differently compared to watching a video recording.
Right.
The exact same lecture as recorded mind one.
Yeah, and I mean, in the video lecture, you can't adapt to your audience because it's already happened, right? So I could also explain my findings of the lab versus video temporal trends in mind wandering.
A couple of really quick questions.
A couple.
These super quick ones though. So media multitasking. The distinction between intentional and unintentional mind wandering, could that be even applied to technology use? Like, for some students who use technology a lot, could it just be unintentional at times?
That's
Or
an
imagine-
I find myself checking my phone for no apparent reason, realizing that I've done it. So I'm sure it's possible. I haven't looked at it, but I would imagine, yeah.
The other quick one was, you found that in lectures, really fascinating that mind wandering stays constant, whereas technology increases. Why do you suppose the results are, very speculative question, why do you suppose the results are that way, not the opposite? In terms of like technology, it's flat.
Right. So one kind of major thing about using this app instead of the clicker is that the students that we're getting data from are the ones that are bringing their laptops to class. So maybe they're also more predisposed to engage with their technology than they would be to escape the current task internally. So that's tricky because the only other option is we also put it on a smartphone, which again is another form of media multitasking. So it might be the case that it'd be the other way if we had data from those students that aren't bringing their laptops every day. It's just hard to get. I mean, there's some people looking at this tech abstinence stuff. I think Dan's lab is actually looking at this, where people pouch their phones before they come into a lecture, and then you look at how that influences their engagement. So that'd be one way to get at it. Yeah.
Thanks so much, Jeff.
Thank you.
Second floor for some wine and cheese. You have a chance to ask more questions of Jeff as well. Thank you.
Thanks.